EVPN VXLAN in data center. Hello everyone, this is NetMaven. In traditional layer 2 network, reachability information is distributed in the data center through flooding. With EVPN VXLAN network, this activity moves to control plane. EVPN is an extension to Border Gateway Protocol (BGP) that allows the network to carry endpoint reachability information such as the layer 2 MAC address and layer 3 IP access address. So this control plane, we call control plane, technology uses MP-BGP for MAC and IP address endpoint distribution, where the MAC addresses are treated as a route. Because MAC learning is now handled in control plane, it avoids the flooding typical with layer 2 networks. EVPN can support different data plane encapsulation technology between EVPN VXLAN enabled switches. All these switches. With EVPN VXLAN architecture, the VXLAN provides an overlay data panel encapsulation. So network overlays are created by encapsulating the traffic and tunneling it over the physical networks. The VXLAN tunnel protocol encapsulates the layer 2 Ethernet frame in the layer 3 UDP packet. What we have packets like this, the UDP, we have the VXLAN packets. This will enable layer 2 virtual networks with a subnet that can span the underlying physical layer 3 network. The device that performs the VXLAN encapsulation and the decapsulation is called VXLAN tunnel point. Here is the VTAP. EVPN enables the devices acting as VTAPs to exchange reachability information with each other about their endpoints. In the VXLAN overlay network, each layer 2 subnet or segment is uniquely identified by the virtual network identifier we call it VNIs. And VNI segments traffic the same way that a VLAN ID segments traffic endpoints within the same virtual network can communicate directly with each other, where endpoints in different virtual networks require a device that supports inter-VNI routing. In my Cisco modeling lab will build the EVPN VXLAN fabric. I'm using Cisco Nexus 9K switches to build the fabric. Now allow me to talk about the lab details. We have the spine layer. These are my spine. And my leaf layer. These are my leaf. And what I have here is my border leaf. Is providing ISP connectivity. I will have ASA Firewall is acting as gateway for all internal VLANs. We have the iOS routers to mimic the ISP setup. Now we'll talk about the underlay. An underlay network is the physical network over which the virtual overlay VXLAN network is established. So in the BGP EVPN VXLAN, the layer 3 underlay network transports the VXLAN encapsulated packets between the source and the destination the VTAPs and provide them reachability. The VXLAN overlay and the underlay IP network between the VTAPs are independent of each other. I'm using here OSPF. You can use also BGP to construct this. For underlay, build a L3 fabric. This we talk about the underlay. For overlay is an network that is the virtual network that builds over the existing L2 or L3 network by forming a static or dynamic tunnel that runs over the top of physical network infrastructure. So it's my VXLAN. Its overlay is underlay. In the context of BGP EVPN VXLAN, VXLAN is used as an overlay technology to encapsulate the data packets and to tunnel the traffic over the L3 network. The VXLAN creates an layer 2 overlay network by using a MAC, is called a MAC in UDP encapsulation. An VXLAN header is added to the original layer 2 frame that is then placed within the UDP to IP packet. So the VXLAN overlay network is also called VXLAN segment. So only the host devices and the virtual machines within the same VXLAN segments can communicate with each other. All right. Now let's take a look at the spine. Spine switches. Here is my spine. Spine have a fairly simple configuration. It runs OSPF, BGP, multicast services only. They do not know anything about a VXLAN because its job is just to push the packets between leaves. Now let's just configure the spines. Spine 1 we have here will be enabling a few features. So NV overlay EVPN. Feature OSPF for my underlay feature BGP. Next, we'll enable feature ping, of course, for the bomb traffic, and make sure using the jumbo frame in the fabric to allow sending more data in single packet. How do I do that? We'll go policy map, type is network dash QS, say jumbo frames. We'll make a class, type network QS, make a default MTU 9216. Okay. Then system QS. We'll say service policy type network QS jumbo frame. Now let's configure multicast for bomb traffic. We're just gonna enable ping RP address, make 10.255.0.123. Let's group my range 239.0.0.0.8. IP ping SSM range 232.0.0.0.8. range. IP ping anycast RP 10.255.0.123, 10.255.0.1. 10.255.0.1 is my spine 1, and we make a spine 2. After defining the ping, we'll have to configure two rollback interface to which later we use for IP unnumbered setup and the multicast RP. So what I mean is I will create a rollback, make sure it's useful, um, route ID, BGP, and it's useful, my overlay. Okay, IP router, we say underlay area. We have to create OSPF first, enable the OSPF process. Router OSPF underlay router ID 10.255.0.1 locked neighbor change area everything. That's fine. Let's just do this, and we'll go to create my loopback 0 IP. And IP ping sparse mode. Show run interface loopback 0. That's my first loopback. Next, interface loopback 1. This for my anycast RP address. IP IP ping, enable ping, sparse mode. Okay, show run interface loopback 1. My other loopback 1 is here. Alright, then we're gonna enter interface E1, 1, 2, 3. Okay, what description is 2 leaves. Okay, no switch port first, MTU 9216, medium, we say P2P, IP unnumbered, unnumbered, following the loopback 0 IP, IP, OSPF network, point to point, IP router, OSPF, say underlay area 0000, IP ping sparse mode, then shut down. Show IP router interface brief. Here you go. We have enabled OSPF on these interfaces. Let's take a look at the BGP configuration. BGP router BGP 65001 is my AS number. Router ID 10.255.0.1. Lock neighbor change. When creating template, we'll call peer VXLAN, say is for leaf. Okay. Remote AS 65001, saying AS update source in my loopback 0. Address family IPv4, enable unicast. Exit is address family at L2VPN EVPN with send community and send community extended. It's gonna become my RR. Is how the RR configure is. And first neighbor leaf 1A 10.255.1.1. This is my leaf 1 neighbor. Will inherit the peer template. That's gonna be VXLAN leaf. Next neighbor dot 2 leaf 1B. Inherit same. Next neighbor 10.255.1.11. That's my leaf 1 on right. So this is my border, and I have my leave 1A and leave 1B, and my leave 2. So let's do it. Just delete this neighbor, next neighbor, 10.255.1.11. Then the neighbor, next neighbor is my leave 2. Inheritance. Then show run BGP. For neighbor, as expected. Alright, that's my spine 1. We'll copy and paste almost the same to configure the spine 2. Features, enable the features. Make sure the jumbo frame in the fabric that's allowed to send more packets data in the single packet. Alright, and this is my ping configuration, and I have my on loopback 0 IP address 10.255.0.0.2. So 2 IP was first enable OSPF router OSPF underlay route ID lock the naked change. Okay. Interface loopback 0 show run interface loopback 0. That's how we configure loopback 0 for now. Just the IP router OSPF underlay area. Okay. IP ping sparse mode. Then loopback 1. This is the same IP, exact same IP as the loopback 1 on the spine 1. Okay. So IP router OSPF underlay area IP ping sparse mode. So I just realized I'm missing one interface. We're connected to my border 1. Okay, that's my interface. We'll just configure that interface. Show run interface say E13, interface E14. Copy and paste. Make sure the interface is there. Show run interface E14. Show IP ping interface brief. Show IP OSPF interface brief. There you go. E14 is there. I continue on my spine 2. Next time E1 1 to E14. That's my full interface right here. Okay. Enter the interface range command. Paste all that for the interfaces. Alright. Now show run BGP. We can copy and paste everything to spine 2. There you go. Show IP ping neighbor. Show IP ping interface brief. Okay. Show IP OSPF interface brief. Show run BGP. I made a mistake. Router OSPF 65001. Reminds your root ID is .2. Show run BGP. Show run interface loopback 0 should be different. It's .2. Okay. Show run OSPF. There you go. we took care of the spine switches. Now we're gonna to configure the leaves. Leaf switches runs OSPF, BGP, multicast, VTAP to form VXLAN tunnels between the leaves. In lab, I'm running the Cisco VPC pair switch to create a single VTAP endpoint. It acts like a single switch. In here is a VPC. Okay, so the first of all, we are going to enable a bunch of the new features. It's going to take a bit of time to enable all that features. After that, we're going to enter my QoS template for Jumbo Frame. One thing I have to do is to set up the virtual MAC for the Anycast gateway. Say fabric forwarding Anycast gateway 000 dot dead, say beef, dead beef. IP ping RP address 10.255.0.123. Group is 239.0.0.0/A. IP ping SSM range 23 is a range 232.0.0.0/8. And then we're going to map the VLAN ID with VLAN with a VXLAN ID. It's also called VNI. We have a VLAN 444 and a VLAN 555, a special VLAN. VLAN 444 used for VPC setup and 555 used for inter VLAN setup. So let's do it. VLAN 60, name is operations, VN 160. VLAN 61, name says sales, VN 161. VLAN 100, name is public, VN segment 10.100. VLAN 444, in this case, we're going to make a name is backup VLAN routing VPC. Okay, VLAN 555 is my L3 VLAN, so VNI L3 VNI is for routing. Okay, VN segment 10.55. We're going to create a VNF. Content is SP VNI 10.555 RD says auto address family IPv4 unicast route target both auto route target both auto for EVPN. That's my address family IPv4. We also have address family IPv6 unicast. Same thing, route target both auto route target both auto EVPN. So we now have a VRF. Then our configure is the VPC. Assuming you know how to set up a VPC, we'll say VPC domain 1 peer switch role peer switch role priority, that's 10. Okay, keep alive peer keep alive one. This is my management interface. keep alive destination. So delay restore, say 90 seconds. Peer gateway, delay restore interface VLAN 36. Okay, VPC down. Next, we're gonna say interface, create interface 100. 100 is my public VLAN to access the internet. So description, say Anycast gateway for public. No shut. MTU 9260. We have member, let's say SP. No IP redirect. IP address. There's a public IP. Fabric forwarding mode and cast gateway. Okay, so run interface VLAN 100. Go. Now I'm going to create VLAN interface VLAN 444 or 555. Interface VLAN 555 444. Description 444 is on delay backup over VPC peer link. No shut. No IP redirect. IP address. Advertise into my OS path. Ping IP router OS path. IP ping sparse mode. Alright, show run interface VLAN 444. That's how I got interface VLAN 555. What makes this interface is a L3 VNI for routing table. No shut, no shut. MTU VF, say member ISP, no IP redirect, IP forward, no IPv6 redirect. Show run interface VLAN 555, my L3 VNI interface. Now creating the MV interface is the VTAP endpoints for VXLAN. No shut. Description say this interface is for VTAP MVE interfaces. Okay. For host reachability, we want to use this protocol BGP. Source is going to be my loopback one. Source interface, loopback one. Member VNI 160. MCAS 239.1.1. VNANA member VNI 161 is VLAN 61. MCAS. See, still saying member VNI 10.100. MCAS 239. Lastly, we'll member VNI 555 is my L3 VNI, just associated VIF, show run, interface MVE1. We wanted to enable OSPF on the late process router ID 10.255.1.11 Lock neighbor change. Say router BGP 65001. Router ID 10.255.1.1.11. Lock neighbor change. Template is gonna be peer. Say VXLAN underscore spine. Remote is 65001 65001. Okay, update source loopback 0. Address IPv4 unicast. Address L2 VPN EVPN. Similar when we configure the spines. Spine extended. We have two neighbor. One spine 1 and one spine 2. So neighbor 10.255.0.1, which is going to inherit the VXLAN spine template. Next, inherit say peer templates. Next, spine 2, inherit the same thing. We have VIF, core ISP, lock neighbor change, Azure family, IPv4, unicast. We want to redistribute. We want to distribute direct routes, route map, direct, permit all. Okay. Address family, IPv6 in case with the ISP you have IPv6. Do the same thing. Redistribute the same thing. Now, show run BGP. This should be everything we have. We haven't created the, the route map yet. We just say route map, direct permit 10. Give a description. This to route map for BGP to distribute the routes. Okay. Lastly, it should be EVPN. VNI, just state EVPN 60 is gonna be my L2, RD auto route target, both auto. Okay. Next, show run BGP to the end. You'll see the config is here. All I do, copy this. That was a VNI 161 L2, paste. Next VNI 110.100 L2, paste. Show run BGP. This the EVPN we have for import export map with VNI, and show run interface loopback 0. I don't have it. That's we should do this earlier. So this gonna be my route ID for route ID BGP overlay blah blah. It's gonna be do that IP address 10.255.1.11, right? IP router OSPF underlay area. Okay. IP ping sparse mode, don't miss that. Interface loopback 1. Description is made by VTAP overlay IP address 10.255.255.11. 32. Want to make 10 as my secondary. IP router OSPF underlay area. Okay, IP ping sparse mode. Show run interface loopback 0. Show run loopback 1. Now here you go. I realize I need to go in E11, E12 for the uplink switch, right? So no switch port, MTU 9216, median is medium P2P, IP unnumbered, loopback 0, IP OSPF, network point-to-point, IP router OSPF, underlay area, IP ping sparse mode, no shut, show run interface E11. Here you go. Show IP ping neighbor. Yes, show IP OSPF neighbor. Here you go. What we're gonna to copy and paste to my leaf 1B is this leaf. Do the same thing. My policy map for jumbo frame. Fabric forward MAC address. That beef was set up for multicast. And also my mapping, VLAN mapping, VLAN ID with VXLAN ID VNI. Here you go. My special VRF, ISP VRF. Also my VPC domain. Let's then create my VLAN 100. That is my public VLAN to access interface internet. Also, this is my 2 VLAN 444 and VLAN 555. Paste that in. My MVE interface. Next, we'll paste in my route process for OSPF and the BGP. Show run OSPF. Show run BGP. Here. Remember to change your route ID, okay? So next, my route map for direct route redistribute. Have a neighbor to the BGP as a router. So run BGP. Again, we have the EVPN, we have content, everything's there. Go to leave one, show run interface E11, show run interface E11. These are gonna to get for the ports, same thing to ports, interface E11 to 2. Paste that in. I also need to know what is my loopback 0 interface, show run interface loopback 0. Yes, we're gonna unnumber to this interface from my physical interface uplink and my loopback 1. Show IP OSPF neighbor. Wait a second. Show IP OSPF neighbor. I don't have. Show run OSPF. I don't have this. This seems wrong. No. Router OSPF underlay. Router OSPF underlay. Show IP OSPF neighbor. Okay. interface rollback 0. Show IP route for SPF. Okay, this is all I have for spine 2. Leaf 1B. Move over to my spine 1, show BGP L2, EVPN EVPN summary. You can see neighbors are up, leaf 1A and leaf 1B are up. Okay. Now let's configure leaf 2. Okay, leaf 2 the same. I'm gonna configure all the enable all the features sets. Leaf 2. Enable jump proofing. Forwarding. MAC address. Multicast. VLAN mapping VLANs. VNF. I'll press it really quick. This is my VLAN 100. My VLAN interface. So run interface. Full. 555. Go. And my MVE. So run interface MVE1. Go. Then is my OSPF and BGP configuration. Run maps. EVPN. My two loopback interface. So run interface loopback 0, loopback 1. Then I'll take a look. Here I have two interface uplink. Now interface E11, 2. Paste that in. Enable interface. Show IP OSPF neighbor. The neighbor's up. Show IP ping neighbor. My underlay is up. Show the BGP. Show IP route. OSPF. Have the route. Let's see the neighbor again. Yes, I have 3 neighbors, 3 leaves. Leaf 1A, leaf 1B, leaf 2A. Okay, I'll go to my leaf 1. I know we have VPC, so interface port channel 999 switch mode trunk with switch trunk allow VLAN 60 to 61 100. That's what you have, right? 444 555 spanning tree port type network VPC peer link. Show run interface port channel 999. Okay, that's what I have. I'll paste these to my leaf 1B. So run interface port channel 999. Now we're gonna go to my leaf 1A. We'll go to interface 1324. Okay, we're gonna switch mode trunk. Switch mode trunk. Switch trunk allow VLAN again 60 to 61, 100, 44, 55. Okay. Channel group 999 mode, say active. Should run interface 1, 3, and 4. We'll do the same thing to my leaf 1B. Paste that. Now show VPC. Peer link is down. Peer is alive. Refresh it again. See port channel is up. Adjacent OK. Peer is alive. Configuration consistent status is success. All right, we're gonna talk about a stop here, and this video we took care of my leaf configuration, spine configuration, OSPF, BGP, all there. I can see 3 neighbors to my leaf 1A, leaf 1B, leaf 2A. That's what we're gonna take care of. Next is the border 1A, and etc. And stay tuned. Still the part 2 of the video. Thank you.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.